So yesterday we did add two numbers. So today we had some kind of an idea for how we would solve this. We walked through, we used Vim to be the debugger and walk through the example inputs. And we came up with some idea for how we might do it. Um, it's kind of similar to the solution we found, but we're going to learn from other people's code and learn from their solution. So this is Java. So maybe the first thing we'll do is just convert this to Python. And then we'll walk through. So the plan here is convert it to Python and then walk through examples with it. Okay, so let's do that. We can just go like this. Okay, so let's see. So C1, C2, not really sure what those are. Another cool thing about rewriting code is like you can rename the variables if you want to. So we might do that once we figure out what C1 is. Okay, Sentinel D is Sentinel. Not sure what's going on here. Okay. Okay. Not sure if you can do that in Python. Let's test. Yep, you can do that. Let's go like this. Search for null. We're just going to turn that into none. Cool. Okay. We're not going to be, we could create, it's going to be hard to run on our own computer, so we'll just run it on LeetCode. Okay, so the goal here is to understand this example solution. So let's read through this. C1, C1, C2, we're just using those. We're renaming L1 and L2 for some reason. Okay. Sentinel, we're not sure what these things do, but we're going to read through and see. So it looks like we're going to do a while loop. Okay, so it looks like we're gonna have pointers to our two lists, and it looks like we're gonna walk through each of our two lists. And once we reach the end of them both, we're gonna hop out of this loop. Okay. Sum, we're going to, so if it's 100, then it's going to be 10. If it's 10, it's going to be 1. If it's 1, it's going to be 0. I believe this is in Java, integer division Java. I'm not sure if they want to do like float division or integer division. J shell, can I do that? J shell. Okay, so this looks like it's integer division, right? Because 101 divided by 10 returned 10. Okay, so yeah, this is integer division in Java. And this is, okay, so we have to go like this, I think, in Python. Okay, so there's the one little change we made there. Sum, so this is a reserved word in Python, so I'm just gonna make this total. Search for sum, replace with total. Okay. If end of list 1, not sure why we're using this C1 and C2. So we can check if we need this by just running it. Okay, so C1. Let's just replace C1 with C2, or with L1. Search for C1, replace with L1. Okay, so let's see if this works. Maybe we need those. Yeah, so we don't need, I don't know why he had those. We're just going to get rid of those. So let's search for C2, and replace it just with L2. Delete that. Let's search for C1, replace it with L1, and delete that. Okay, cool. What is D doing? What is Sentinel doing? So when we update D, Sentinel is going to point to the head, I believe. I don't know why he calls it Sentinel. I'm just going to call it head. Let's do the same thing over here and just make sure we can just keep running this to make sure that it's passing all of the tests. So let's run that. Cool. Yeah, so first thing you want to do when you're understanding someone's code is you can just rename the variables to something that makes sense to you. And as long as it passes all the tests, which it has, then you're not changing the logic. Okay. And D, what does he mean by D? It's just a variable name. That's okay. Just call it I. I don't know. Do what's comfortable for you. So personally, when I do a pointer, I call a pointer I. So I'm just going to call this I. What? Yes. No. Okay. So we got our pointer I. Okay, let's make sure this is still running. Uh-oh. So now we know we made some kind of a mistake. Interesting. So this one does work. Interesting. So the mistake I made there, I wasn't running this code against the tests while I was changing it. Let's go back to a working state. Okay, let's see if this one works. Oh, we have to. Okay. Okay, let's check that this works. Huh. Oh. This isn't working. Interesting. Can we go further back? Okay, what we can do is we can just walk through, let's try and understand the intuition of this, and then we'll write it in Python. Because there might be some like little differences between the two languages. So here's the plan. We're not going to change this code. We're just going to walk through an example with it so that we understand the intuition. Then we can rewrite it once we got something that's working. Okay. All right, let's walk through some examples. All right. Okay. We're going to be a human debugger. It's going to help us understand what's going on. So C1 is going to point here. C2 is going to point there. Okay. Sentinel. I'm just going to rename Sentinel S. I'm going to rename Sentinel Head. Okay, let's run this and make sure that we didn't break it. I'm a fan of running the code early and often. Experiments are cheap in programming, so you should do many of them. Okay, so head is going to start off as 0. D is going to point here. Sum is 0. Sum is 0. Okay, so we're going to keep track of these variables and walk through this example. So while C1 is not null, okay, so both of these, so the last one is always null, null. That's because here we set it as the default value. Okay. While C1 and C2 are not null, or C2 are not null, we're going to do, this is, let's write a note, integer division. In Java, float in Python. We figured that out by just running some examples. Okay. Sum divided by 10 is still 0. If C1 does not equal null, it does not, then let's add C1 value to sum, so plus 2, and let's update C1, go like that. If C2 is not null, add it to the sum, 7, update C2. Update D, so D is now on null. Interesting. Oh, D.next, we're updating this one. It's going to be sum modulus 10, which is the remainder. So 7 modulus 10 is 0. So make this 0. And we're going to set D to D.next. Okay. And now null is here. Cool. So we're going to keep going until C1 and C2 hit the end. Okay. Sum divided by, or divide sum by 10. So it's 0. Okay. Interesting. So now we're going to, I'll put an arrow to show where we're at. Go like that. So we're right here. So sum, we're going to add C1, 4. And we're going to update C1, 3, 19 down. So this goes here. So we're going to update sum with C2, so 10, and we're going to increment C2. And then we're going to set D.next equal to a new node. 10 modulus 10 is 0. And we're going to set D to that new value. Okay. Okay, now we're back up. We're back here. C1 is not null, so we're going to add its value to sum. Well, actually, first we got to update sum. So sum 10 divided by 10, it's 0. Or 1. Wait, 1. Crap. Integer division, 1. 10 divided by 10. Integer division is 1. Yep. Okay, sum is 1. C1 is not null. So let's add its value to sum 4 and update it. Now null. Okay. We go to the next if. In this case, C2 is not null. So we're going to add C2 to sum and update C2. It's null. Now we're going to move this here. Okay, we're going to set D.next equal to a list node. 8 modulus 10 is 8. Wait, I think I messed this up somehow. Maybe. I don't know. 708. So it looks like somehow I missed setting this to 7. Oh, and where's head? We haven't been keeping track of head. Dang it. So head started off here. Crap. That's okay. I think somehow we made a mistake where this is supposed to be 7. Oh, at some point this was 7. 7 modulus 10 is 7. So we made a mistake there. So probably when we were here, when we started off, sum starts at 0. C1 is not null, we add C1, so 2, we add C2, 7, we update C1 and C2, and then we set, in this case D was here, we set D.next equal to a list node 7 modulus 10 is 7. Okay, that's the mistake we made. Got it. Okay. So we made that mistake. That's okay. So we were here. We fixed our mistake. C1 and C2 were on null. How are we, I mean, we have to do another example. I'm not seeing how we're carrying a number. Like when it's, we've seen when it's like, less than 10. What about when it's 11? Like, how does the next value get carried? I'm not sure. Oh, because the remainder gets carried in sum. Okay, I'm going to call sum, I'm going to call this the carry. Because this is the value that we're going to be carrying to the next spot. So it's renamed a variable, so that should still work. Okay, so let's make sure this is still working. Okay, and then I just got to remove C1 and C2. And search for C1, replace with L1. Search for C2, replace with L2. Alright, now let's check that it runs. Delete these. Yeah, okay, so we didn't need those things. So just renaming some stuff. That's okay. Makes a little bit more sense in my head. Okay. I say carry because like 909, 909, when you're doing addition, you start at the end. This is 18, so we put 8 here, and then we carry the 1. That's what I mean by carry. So the second one is going to be 1. This is going to be 18. This is what the carry is in my head. This is what I'm thinking about when I say carry. Okay. This kind of makes sense. Let's do another example. Let's do this one. Just setting this up. Okay, let's walk through this example. L1 and L2 are not null. Let's update carry. L1 is not null, so let's add its value to carry 9 and update L1. L2 is not null, so let's update carry 18 and update L2. Okay. So now we're right here. We're going to set d.next equal to the ones digit of carry, so 8. And we're going to set d, let's add our nulls, and update d, null, null. Okay. Now we go back up to the top of the while loop and we update carry. So we're doing integer division. So we're going to carry the 1, just like we did with our example. Nice. Okay. Yeah, so a couple good strategies here. Rename the variables to something that makes sense to you, and walk through the code using Vim as the debugger. This is helping me at least understand how this code is working. Okay. 7 up. All right. L1 is not null, so let's add the value to carry. So 10. Update L1. Okay. L2 is not empty, so let's add its value to carry. 19. Update L2. Okay, so now let's set d.next equal to 19 modulus 10, which is 9. Oh, and h is pointing right there. Set d to d.next. Let's go back to the top of the while loop. Update carry. So 19 integer division by 10 is 1. We're carrying the 9. Leave the 9, carry the 1. Got it. Okay. So L1 is not empty, so let's add its value to carry. 10. Update L1. L2 is not empty, so let's add it to carry. Update L2. Okay, so now let's set d.next equal to 19 modulus 10, which is 9. Update d. Go back to the top of the while loop. Update carry. 19 integer division by 10 is just 1. Leave the 9, carry the 1. Nice. Starting to see a little bit about what's working here. It's like a different version of what we were doing. We were doing 3 while loops, so just doing 1. Okay. Okay, so keep going until these are both done. So let's see, so L1 not empty, add it to carry, update L1. L2 not empty, add it to carry, update L2. L2 is now null. Okay, so let's set d.next equal to 19 modulus 10, which is 9. Update d. Go back to the top of the while loop, update carry. The remainder is 1. The carry remainder. Okay, so L1 is not empty, so let's add it to carry and update L1. Okay, so now in this case L2 is null, so we're just going to skip this one. L2 is null, so we're going to skip this one. We're going to set d.next. d.next equals 10 modulus 10. The remainder is 0. And we're going to set D to 0. We're going to go back to the top of the while loop, and 10 modulus 10, or 10 integer division 10 is 1. Wait, yep, leave the 0, carry the 1. Yes, this makes sense. Okay. So L1 is not empty, so let's add it to carry. Update L1. Okay. L2 is null, so we're going to skip it. So we're going to set d.next equal to 10 modulus 10, which is 0. Update D. Go back to the top of the while loop. Update carry. 10 modulus 10 is 1. L1 is not empty, so add it to carry. Update L1. L1 is now null. L2 is null, so we skip it. So we set d.next equal to 10 modulus 10, which is 0. Update D. Go to the top of the while loop. Carry 10 integer division by 10 is 1. L1 is null, so we skip. L2 is null, so we skip. So we set d.next equal to 1 modulus 10, which is 1. Set D equal to 1. Okay, so now we go back to the top of the while loop, and in this case, L1 equals null, L2 equals null. So we hop out of this while loop and we go here. Wait. Wait, what happened here? Oh, I think I went one step too many through the while loops. I think that's the issue there. Okay. So carries 1, we hop out of the while loop. And is this... I think I did one too many loops of the while loop. Because 1 divided by 10 is 0. Oh wait, maybe I didn't? Hold on. 1 divided by 10, let's just check. J shell. One divided by 10. 0. Okay. We're going to return head.next. So we're going to return this guy. 8990 8999 8999 Okay, so the key things to know here are we set the next value to you know, the sum, the current sum. I guess I mean, sum does make sense. It does make more sense here. Search for carry, replace it with sum. And then what after you do, so the remainder, or the carry, so we add the two values. We add L1, L2 values. The remainder, or the carry, is integer division by 10. So like for 19 was a number we saw constantly. So 19 modulus 10 is 9. We leave the 9. We bring the 1 with us by doing integer division by 10. 19 integer division by 10 is 1. So we leave the 9. We bring the 1 with us. So each iteration, looking at each value on the linked list, that's a sum. And whatever is, left after we divide by 10 here, that's our carry. So we're calling this sum is a better name for it. And the remainder at this step, carry 10's digit, leave 1's digit. So with 10, 10, 0, 10, 0 is 1's digit, 1 is 10's digit. Ten equals 0 times 1 plus 1 times 10. So we're leaving 1's digit here. We're carrying the 10's digit here. Okay. So let's try and translate this to Python. So the key point is to add current values. So let's talk about this in English and then write it in Python. So we add the current values. Add the current values. Leave the 1's digit and carry the 10's digit with us. Leave the 1's, carry the 10's. Okay, got it. So we're going to have head equals a list node, starting off as empty. And for a pointer, I mean, we could just call this current. D doesn't really make any sense. I'm going to call it current. Head and current, set them equal to the same things. I guess we don't want to copy, we want them to point to the same thing. So let's set cur equal to head. And sum total. Sum is a reserved word in Python. It's a function. So let's call it total. Total equals 0. While these are not empty, while L1 does not equal none, or L2 does not equal none. We're gonna remove the 1's digit from total so that we're left with carry. How do we do that? Total integer division by 10. This chops off so for 10, for example, it will chop off the 0 and leave 1. For 101, it will chop off the 1 and leave 10, for example. Wait, what? (101) modulus 10, or integer division by 10 is just 10. So it chops off the 1 and carries the 10. 11, chop off the 1, leave the 1. 13, divided by 10. Chop off the 3, leave the 1. Okay. So this one is chopping off the 1's digit, leaving the 10's digit. Then what are we going to do? We're going to say if L1 is not empty, L1 is not null, none. We're going to add L1 value to total and update L1. We're going to do the same for L2. Then once we update our total, 18, we want to leave we want to leave the ones digit. So cur.next equals list node. Leave the ones digit. How do we do that? Total modulus 10. 13 modulus 10, 3. 11 modulus 10, 1. So we're just taking the ones digit with modulus 10. We could rename this a lambda function, leave ones. Leave ones digit. And then we can rename this get ones digit, get tens digit. I actually like this better. And now we don't have to like think about what's happening here. Get tens digit. In our head, we had to convert what was happening here. So now we can just read it in English. We're getting the tens digit. We're getting the ones digit. Let's see what's happening here. One. That's pretty cool, right? Get ones. You see what's happening there? So we're grabbing the ones digit. We're grabbing the tens digit. Pretty cool, right? I like that. Okay. So now it's clear, like this is the carry value. This is what we're leaving behind. We leave the ones digit, we carry the tens digit. Nice. Okay. So we go through this until we reach the end. And then I guess, I'm not sure, we can run this. So this is probably like for some edge case. This isn't like apparent right away. So maybe we'll let's run this without this and see which case this will fail for. Okay, so once we get to the end of our lists, what are we going to return? So we set current equal to head. So head should equal current, except head is starting at 0. So if we return head.next, we get the first value. See here, head starts at 0. So if we return head.next, we get the correct answer, which starts at 9. Okay, so This is going to fail because we don't have this, but we want to see what. Let's think. Oh, this is the case where, let's give an example. So like 909 plus 909. So 8, carry the 1. 1. 18. So 8, and so there's a 1 remaining after we exit the while loop. In this case, so with that 1 remaining, so 18 integer division by 10 does equal 1. This is for like this last case. We need to add this additional 1. Boom. Yeah, this is for the when we get to the last value and it's greater than 10. We need to add that 1. Okay. So we know why we're doing that. If total last total greater than 10. We could also just do greater than 10. If total is greater than 10, in this case, we call it, okay, this is supposed to be sum. This is the same as we could say if sum is greater than 10. It should be the same. We can check. If total greater than 10, then we want to add d.next list node 1. Okay, let's check. Gotta pass the test cases. Uh-oh. Huh. It looks like head.next is 8. How does that happen? So it's trying to debug why we're getting 8 and not 708. So let's print out Oh, D? What is D dot next? Cur. Is that the issue? I don't think so. Let's see. 8. Yeah, why are we getting 8? So let's print list. Let's see what head is as it walks through the for loop. 0, 0. Oh, we're not updating cur. Is that what happened there? I think that was the problem. Let's see. We kept updating the same value, right? Yeah. Okay. I think that was the issue. Oh, what if it equals 10? That's the problem. There we go. All right, you guys, we figured it out in Python. Okay, so let's recap what happened here. So the idea is we're going to walk through each of our input lists, and as we do, we're going to add the values to a total. We're going to leave the ones digit, and we're going to carry the tens digit with us. Leave the ones, carry the tens. Cool. I think it's hard to understand these like inner for loops here. So that's why I like the idea of 3 while loops. I don't know, I guess it's the same. All right, so we figured out we used someone else's code to get some intuition about this problem. That's always nice. So we can leave a comment. We can say in Python. So the next person doesn't have to convert this. Cool. You could also leave this as, I mean, this is like, I don't know. I always look for most votes. So these top votes, these top ones, like I don't just look through like newest to oldest or hot or something. I just go with top votes. I don't know. Maybe other people do something different. I'll just leave that comment. Okay, so let's do a new problem. What's up, Asif? Thanks for joining. All right, let's do. I think I tried this one. Is that what that means? Let's do it. Longest substring. Okay, given a string S, find the length of the longest substring without repeating characters. ABC A repeats, so 3. ABC ABC B. That's repeats, so 3. Do we BCA? BCAB. We could find all non-repeating substrings and then okay, so we could find all non-repeating substrings, return length of the greatest. So say we have, how do we find all non-repeating substrings of this one? Okay, so all non-repeating substrings, so A B, C, obviously. A, B, C, A, B, B, C, C, A, C, B, A, B, C, B, C, A, C, A, B. I can think of some ways to do this, but I think they would not be so efficient. Like we could find, we could find all combinations of 1. We could find all combinations of 2 up to the size of the string. Then just find all the unique ones. That's like an n squared. You know, n choose 1 is n times n minus 1 over 2. Wait, no, that's 2. n choose 1 is just n choose 2 is this, n choose 3. This is n cubed. Oh boy. Yeah. So n choose n minus 1. We could keep a set. Seen as a set. We could iterate over our string. We could iterate over s. Keep seen. B. And while we have not seen 1, we'll keep updating our max to C 3. Okay, seen. Now we have seen something. So what do we do in this case? This is n squared, I think. But it is a solution. It's better than this, which is like n cubed. I don't know. This is like worse than n squared. So max is 3, we've seen so far. So we start here, we see B, max, cur max, equal 1, C, 2, A, B, seen. Okay. So we update our max, we update this. This is going to be n squared solution. Not sure if it'll pass. Let's see. So n squared. Ten to the 8th. I think it's going to be too slow. N squared is going to be too slow. Given a string, find the length of the longest substring without repeating characters. You can't sort it. That's not the point of this problem. So I think we have an n squared solution. So let's call it brute force, I guess. Brute force O of n squared for for char and string, for char and string, for char and string. I guess we could do like index. Like when j is here, we don't need to look here because it's not a substring. Well, I guess it is a substring, but we've already looked at it when j was already down here. So we're only looking at I values that are equal to or greater than j. Okay. For char and string at same or greater index, we'll figure out the specifics later. For char and string, and let's just call it C. Let's call it I and j. For j, for I in string at same or greater index, if I is in scene, what do we do? If I in scene, we're going to set max equals max of max and cur max. Break out of this inner loop into the top loop. Reset scene. Update the global max, reset scene, break out of this loop. Otherwise, if it's not in scene, cur max plus equals 1, scene dot add I, and so this is going to be O of n squared and O of n space. O of n squared time and O of n space. I'm not sure how to do better than that. I think I remember doing this problem and there was like some trick that I just couldn't figure out. That's okay. Like you practice the tricks and like once you remember it, like you figure out the trick, you can use it in future problems. So you're gaining a new tool every time you learn a new trick. Okay. Let's think of what is there any repeated work that we're doing? What work are we repeating here? Let's think. C. Let's see if we can find any repeated work. CA. CAB. 3. And so now C is in scene, so we update max. We reset we update J. So now we're looking at AB. I guess we're checking AB again like multiple times we're checking this current AB value right here. So let's think if we can do better. So for example, at the beginning of the string, we find that ABC is the longest substring. Like if this is D, we can't skip B in this case. Like we can't go from A to A because we would miss BCAD. BCAD. I don't know the trick, so let's find it. The basic idea is keep a hash map which stores the characters in string as keys and their positions as values, and keep two pointers which define the max substring. Move the right pointer to scan through the string, and meanwhile update the hash map. If the character is already in the hash map, then move the left pointer to the right of the same character last found. Note that the two pointers can only move forward. Okay, so when this is B, so we're doing two pointers. We're keeping a hash map. Okay, A, B, C, A, B, C, A, we see the same scene. Okay, so how are we using the hash map? That's not clear in my head. Let's see what they're doing here. Character integer. Max is 0. We're iterating through S. J. Let's walk through an example to see if we can get an intuition for how this is working. Okay, so we're going to keep track of I and J. We're going to keep track of a map. Okay, so let's try and get an intuition for what this solution is doing. Okay. And ++I, does this mean it's updating? Does I start at 1? plus plus I Java. I guess we can do a for loop. Hmm. Okay, interesting. Is this the same? So it's the same. That's weird. I guess it doesn't make a difference. Yeah, if anyone knows why you would do that, let me know. Okay. Not sure what's going on there. Maybe it's some optimization. Let's see if this works. It should work. Java. So the only thing I did differently is move the plus plus thing. It probably just makes it faster or something. Oh wait, what? Oh. Okay, so it's probably just faster or something. No, it's not faster. I don't... Yeah, okay. Alright. Let's walk through this example and see what's going on here. If map contains I, it does not. So we're going to put a, comma, 0. A0. Max, okay, so we're keeping track of max too. Max starts at 0. Max equals the max of max, and okay, let's just keep track of that. I minus j plus 1 equals I minus j plus 1 is 1. In this case, 0 minus 0 plus 1, 1. I minus j plus 1 is the number of characters in between I and j. So the max we've seen so far and the current length of our substring. Length of substring between. Okay. So we're putting a0. We're setting max equal to either 0 or 1. So we set it to 1. And then we update I. J stays where it's at. Okay. Does the map contain B? It does not. So we're going to put B. Put B and I, in this case, is 1. We're going to update max. Max is either max or length of the current substring, which is 2. So 2. Update I. Is C in the map? No. So let's put it in there. And let's update max. Max is either 2 or 3. 3. Update I. The map does contain A. So what do we do in this case? We're going to update J. J, in this case, J is either 0 or it's the max of either 0 or map or 0 plus 1. What? So we're getting the previous A. So let's, in English, look up the previous. So we found A. So look up the previous A, which is at 0. And we're going to move J to J's current position or the next value after the previous one. Current position or next character after previous. Do we ever update it? Does our map ever get updated? It doesn't look like it. It looks like we're only adding values to the map. We're not updating it. So this is the first A that we saw. This is the first B we saw. It's the first C that we saw. Next character after first scene. Interesting. So in this case, J is either 0 or 0 plus 1, 1. So I guess we're moving J to B. Okay. We can also go like this. 0, 1, 2, 3, 4, 5, 6, 7. So we can keep track of what values I and j are. Okay, so we got to A. A is in our map. So we're going to update J to either its current position or the first scene A plus 1. Or the next character after the first scene. Okay, we're updating J to 1. Oh, it does look like... What? Oh, we are updating A. Gotcha. So it's not first scene, it's current position or next character after last scene. We are updating A. Okay. We're putting A. A is 3. We're updating A to 3. Okay. And now we're setting max to either max or 3 minus 1 plus 1 is 3. Okay, max is still 3. Update J. B, C, A, B. Map does contain B. So we're going to update J to either itself, either 1, or the next character after the previous scene B. Either 1 or 2. So we're updating J to 2. And we're going to update B. B is now 4. We're going to update max. I minus j plus 1 is 4 minus 2 plus 1, which is 3, so max is still 3. Okay, update I. Still not quite seeing the pattern yet. This is kind of weird. What can we call this? Like, that makes more sense. Int next index Okay, so last thing we did is we updated B to 4. The substring length is Oh, looks like we moved I. Okay, so we moved I. So now the question is, have we seen C before? Let's call this Boolean if seen before. Man, this is hard to read. Okay. So C, have we seen it before? Yes, we have. So the next index is is 3. So we're going to set J to either 2 or 3. 3 is greater, so we set it to 3. And we update C. This is now 5. The current substring length is, oh wow, wait, ABC, right, okay. The substring length is 5 minus 3, 2, plus 1 is 3. Okay, so we're not updating yet. Update I. Have we seen B before? Yes. So the next index is 5. Oh wow, so we can really jump here. The next index is 4 plus 1, 5. Set J to either 3 or 5. Okay, so we're setting J to 5. Wow, why can we hop so far? Wait. Why can we hop to 5 at this point? Man. I don't understand why we can make that hop. Okay, so we hop to 5. We put, for B, we put 6. Current substring length is 6 minus 5, 1 plus 1, 2. So we do not update max. 2. Okay. Move I. Have we seen B before? Yes. So next index is 7. Wow. We make another jump. J equals either 5 or 7. We put, for B, we're putting 7. Substring length is 1. So we do not update max, and then we return 3. That was a tough one. But we did at least make an improvement, like we pulled these values out of the max. It was hard to read. Substring length. At least we made it a little bit more readable. a bit more readable. I'm not seeing it. Let's see if someone has some kind of a intuition. I also don't understand this point. So just trying to understand the jump. Like here we jump from 5 to 7. Why are we able to make that jump? That's the question I have. Why are we able to skip indexes with J? So I'm getting that we need to think about two cases. Either it's the max is hiding this if else statement. So let's see if we can expand it. Okay, now we can think about, by doing that, we can, so they're talking about this if else cases, these case 1, case 2, now we can map it to code. Case 1, case 2. Okay, so let's see if that can help us understand this. J represents the start index of our string. So let's just call it start. Why are we calling it J? I think that's a little bit better. Start and end are clearer. Okay, so we're still talking about the same thing. J here represents the start. Okay, so let's call it start. I is the pointer that traverses the whole string. Say we find s caret. All right, let's just replace I and J with start and end. Because start here represents the start index of our string, we can just delete this whole sentence because um, we've renamed our variables. Wow, this is hard to read. Okay. This is a tough one because the answer was like pretty unreadable. Um, I find this also unreadable because it's so long. Man. All right, guys. Um, yeah. Just keep plugging away, keep chopping away at these problems, learning new tricks, bringing them on to the next one. Thanks for coming.